All right, so far, we've got our basic shapes for x to the n when n is even and n is odd, and for our root functions, nth root of x when n is even and n is odd. We still need to get our basic shape for our absolute value graph, this guy, and for our basic rational functions, 1 over x to the n, where n is even and n is odd. We're going to actually start with our absolute value graph next. So again, let's go ahead and head to Desmos for a minute. So over here on Desmos, we're looking at our absolute value graph. So these lines here mean absolute value, okay? And absolute value, remember, what does absolute value do? Absolute value takes a number inside, and for our purposes, we're going to say makes it positive. We'll talk a little bit more in the next section about what absolute value actually means. But in general, an absolute value graph is only going to have positive numbers. So if I want to do the graph of absolute value of x, right? Well, it looks like this. It's this V shape, right? And that's because everything that you throw into absolute value becomes positive. So when I put in 1, well, 1 is already positive, so it stays 1. When I put in 4, 1 is already positive, so it spits out 4. It's more interesting over here. When I put in, say, -2, -2 is negative, so it's going to spit out a +2. Absolute value makes things positive, okay? So our basic shape is this nice V shape. So our basic, whoa, that's not what I wanted to do, was it? Sorry. Our basic V shape. So let's draw that in there. Okay. Go away. Why are you not going away? Our basic V, the absolute value V. Okay. Now let's think about our domain and range. Well, our domain is everything. That's going to expand and hit all of the x values there. Our range is only going to be the positive values, right? All things above the x-axis, or all positive y values. So positive numbers are 0 to infinity. We're going to include 0, and we never include infinity. Now the nice thing is transformations are going to work exactly the same with our absolute value graph, right? So if we can figure out what transformations we've done, we can sketch a graph of this. So a negative out in front is an x-axis reflection, so that means this graph is going to open downward. We've stretched it by a factor of 2. We've moved to the right 3 and up 4. So let's see if we can do all of those things. So we're going to move right 3 and up 4. So there's where our little V is going to start. Now instead of opening upward, because we've done an x-axis reflection, our V is going to open downward, and it's also been stretched. So I'm going to draw it kind of skinnier than it was before. So there is a sketch of our transformed absolute value graph. So if I want to check it, since I have Desmos pulled up, I'm going to go ahead and do that. So we're graphing -2 absolute value of x minus 3 plus 4. That sure looks pretty similar to what we drew, doesn't it? It's pretty good. So now let's think about our domain and range here. So our domain is still going to be everything, right? This is still going to reach out and hit all of the x values. So our domain is -infinity to infinity. Our range is different though. Think about what our range will be. We want to kind of highlight it. Our range, right, is going to be all the y values down here, right? Eventually this is going to come down and cover all of these y values. So we can think of our range as being all numbers smaller than 4. And how do we write all numbers smaller than 4? Well, we start at the smallest number. Oops, in this case, our smallest number would be -infinity. We're going to start at -infinity. We can also think of this as working bottom to top. So starting at -infinity and going until we hit 4. We're going to include that 4. We never include infinity. All right. So there's an example of an absolute value graph. Now look at this question down here. What would reflecting this graph, that's a terrible circle making, what would reflecting this graph across the y-axis do? Well, if we reflected this graph across the y-axis, right, this guy here, it wouldn't really do anything because that's just flipping this graph across the y-axis. And if I did that, I would get the exact same graph, okay? All right, so if we go back to our chart here, well, we've just done our absolute value graph. The graph of the absolute value function is the V, straight line, the V. The domain of this graph is -infinity to infinity. Our range starts here and goes to infinity, so our range is 0 to infinity. So that's our untransformed graph. If we have a transformation, those things are going to change. All right, so last but not least, we need to think about our rational functions, 1 over x to the n, and we're going to focus on 1 over x and 1 over x squared to get an idea of what these look like. All right, so I'm going to go back to sharing my screen. All right, so now we're going to think about rational functions. We're going to talk more explicitly about rational functions a little bit later in chapter 5. But rational functions basically are functions where we get x's in the denominator. Okay, and we're going to focus on 2 rational functions to start with, 1 over x and 1 over x squared. We're going to try and get a basic idea of what these look like, as well as their domain and their range. Okay, all right. So we're going to start with 1 over x. Now, instead of just letting Desmos graph this, I actually want to think about this for a minute. And so we're going to do a little bit of using Desmos to plot some points. So let's pick an x value, like 1, and what would happen when we plug 1 into this function? Well, I would have 1 over 1, which is 1. So I have the point 1, 1 on the graph of 1 over x. What if we plug in negative 1? Well, if I plug in negative 1 for x, I'd have 1 over negative 1. 1 over negative 1 is negative 1. So that means I have the point negative 1, 1. Negative 1, negative 1 there. Let's how about 2? If I plug in 2 to this function, I'd have 1 over 2, which is 1/2. So I have the point 2, 1/2. Similarly, if I plugged in negative 2, I'd have 1 over negative 2, which would give me the point negative 1/2. Okay. Now, what would happen if I actually plugged in the point 1/2? Well, if I plugged in the point 1/2, I would have 1 over 1/2. 1 over 1/2 is saying if you take 1 and you divide it in half, how many pieces do you have? Well, you'd have 2 pieces. So 1 divided by 1/2 is 2, so that means I have the point 1/2, 2. Similarly, if I plugged in negative 1/2, I would get out negative 2. Okay. Now, what is going on here? This is starting to look kind of weird just by plotting points over here. Now, one thing I want you to think about is what would happen here if I plugged in 0. So what if I let x be 0? If I plugged in 0, what would I get? I would get 1 over 0. Can we do that? Can we do division by 0? No. So it turns out at 0, this function is undefined, meaning there's never going to be a point at 0 or right here on our y-axis. What's happening here is our graph is existing in 2 separate pieces. It's going to exist on this piece, and it's going to exist on this piece. And if I go ahead and tell Desmos to graph it, notice that that's exactly what's happening. We've got what I call a little L curve here and a little L curve here. That's going to be the basic shape for our 1 over x graph. It's going to look like a little, I call them L curves here. An L curve in the top right, and also an L curve, that's a bad L curve, but go with me on the journey, in the bottom left. Okay, so this is the basic shape of the 1 over x graph. It's 2 pieces, an L curve up here and an L curve down here. Now let's see if we can figure out the domain and range of that little graph here. Well, our domain, right, it looks like it almost takes on everything, except it certainly doesn't take on 0. And it turns out what's going on, and we're going to talk about this more explicitly later, but what's going on here is this has what's known as a vertical asymptote right at 0. And a vertical asymptote is a line that this graph cannot cross. It cannot take on that value. Okay, again, we're going to talk more about this terminology later, but essentially that's what is making our graph exist in 2 parts. So that means the domain of this graph is going to be everything except 0, because our graph just can't cross that red line. That makes sense if we look at the function here. We can plug anything in down here except 0, because plugging in 0 would give us division by 0, and that's bad. So our domain is everything but 0. How do we write everything but 0? Well, I'm going to say everything to the left of 0. That is negative infinity to 0. That's actually giving this piece of the graph. Not including 0, because we certainly don't want 0. I'm going to use the mathematical and, which is union, and then I'm going to say 0 to infinity, which is this piece of our graph. 0 to infinity. So there's our domain. Now let's think about our range. Now in terms of our range, Again, we're going to talk about this more explicitly later in class, but this graph also has a horizontal asymptote. That horizontal asymptote is right here at y equals 0. And what our horizontal asymptote does is it governs our end behavior. Again, we'll talk more about this later, but it essentially says on the ends, our graph is going to get closer and closer to those blue lines. Okay? It's going to help us think about, in this case, what our range is, because our range is going to be everything except 0 also. So our range is going to be negative infinity to 0. That's this piece of the graph here, negative infinity to 0. Union, mathematical and, with 0 to infinity. That's that top piece of the graph there. Okay. So here's the basic shape and domain and range of our 1 over x graph. Now, how do we think this is going to change when we change this to 1 over x squared? Well, let's flip real quick back to Desmos, okay? And let's change this to x squared. Now I have said don't graph it yet, and let's see how that changes these points down here, okay? When I plug in 0, I'll still have 1 over 0 squared, which is 1 over 0, which is still undefined. So 0 is still undefined. So it seems like we're still going to have a vertical asymptote right at 0. And I'm going to go ahead and put that in this time and say x equals 0. I'm going to make that dotted so that we can say that that's not part of our graph. Okay? That's going to be a vertical asymptote there. Now when we plug in 1, what are we going to get out? Plugging in 1 will give me 1 over 1 squared. Hey, that's still 1. How about when we plug in negative 1? Well, that's going to give me 1 over negative 1 squared. But what's negative 1 squared? Negative 1 squared is just 1. 1 over 1 is 1. So that point's going to move up to here. How about when we plug in 2? When we plug in 2, we'll get 1 over 2 squared. But 1 over 2 squared is the same thing as 1/4. So now we have the point 2 1/4. When we plug in negative 2, we'll get 1 over negative 2 quantity squared. But negative 2 squared is positive 4. So we'll get the point negative 2 1/4. Plugging in 1/2, oh man, we'll get 1 over 1 divided by 2. Squared, right? That's literally what we get when we plug in 1/2. 1 over x squared becomes 1 over 1/2 squared. 1/2 squared is the same thing as 1/4. 1 divided by 1/4 is 4. So now we have the point 1/2 4. That's this point up here. Negative 1/2 will become 1 over negative 1/2 quantity squared. Negative 1/2 squared is 1/4, positive 1/4. 1 divided by 1/4 is again 4. Phew, so there are some points plotted. Now notice, we're again going to have this graph in 2 pieces. We're now going to have an L curve here in the upper right and an L curve here in the upper left. Let's go ahead and fill those in. So we again have 2 L curves, one up here and now one over here. I'm going to sketch those in. Okay. So 2 L curves, only now they're in the top right and the top left. Okay. Okay, so let's talk domain and range, and that's also going to let us think about our vertical and horizontal asymptotes, just as a little introduction. So I mentioned earlier that this also has a vertical asymptote right here at 0, meaning our graph can't cross that line. Okay. That means our domain can't take on 0, which again makes sense because what happened when we tried to plug in 0? We got undefined. So our domain is negative infinity to 0, throw out 0, union with 0. Oh, I didn't leave myself enough room. I apologize. To infinity. Oh, sorry. We'll make it look neater when I do it on the board behind me. Okay. Now this guy also has a horizontal asymptote. That horizontal asymptote is again right here at 0. The horizontal asymptote just tells us again what this function is doing on the end. So we'll talk about that more explicitly later. Okay. But that also helps us think about the range. Our range is going to be everything above that, or 0 to infinity. So the range of this graph is 0 to infinity. Okay, now remember, the big reason to think about basic function shapes is to help us graph things like this. 1 over x minus 3 plus 2. Okay, so the first thing we need to think about is what is the basic function shape? Well, I noticed that I have a 1 over x, and then I've done some stuff. I added and subtracted some stuff. So this has the basic function shape of 1 over x, which if we remind ourselves up here, are L curves in the top right and the top left. Sorry, top right, bottom left. My apologies. Okay. So here's our basic function shape. Now, because it's going to be helpful for us, I'm also going to remind us that our basic function shape has a vertical asymptote on the x-axis and a horizontal asymptote. Sorry, a vertical asymptote on the y-axis and the horizontal asymptote on the x-axis. Okay. Now, in this case, that's really going to help us when we go to do our transformations. What do I mean by that? Well, let's look. What have we done to our basic 1 over x graph to get 1 over x minus 3 plus 2? Well, we subtracted 3 and we added 2. Where did we do that? We subtracted 3 here with our x. That means this represents a horizontal shift. A horizontal shift right. If I can write it, I shouldn't have done this. Right 3. Okay. This represents a vertical shift up 2. Okay. So to graph this, we want to take our basic function shape, we want to shift it up 2 and right 3. Now here's where those asymptotes are going to come in really handy. It's going to help us to think about shifting those asymptotes and then just drawing our little shapes where they need to be. Top right, bottom left. Okay. So let's think about those shifts. We've got up 2 and right 3. If I think about this vertical line at 0, 0, shifting it up doesn't do anything. It's a vertical line. It goes on forever. Shifting it up, still a vertical line. But shifting right 3 is going to move this vertical line 1, 2, that's left, 1, 2, 3 units to the right. So our new vertical asymptote is going to be at 3 because it shifted 3 units over. So here's our new vertical asymptote. Now what about our horizontal asymptote? Well, our horizontal asymptote is not going to be impacted by moving left and right, but it is going to be impacted by moving up. It's going to move up 2, 1, 2. So our new horizontal asymptote is going to be right here at 2. So what have I done here? I've moved our asymptotes up 2 and right 3. Once I've done that, then I have to say, okay, these are in upper right and lower left. I'm now going to draw those L curves in upper right and lower left. So now we've drawn a nice sketch of this graph, 1 over x minus 3 plus 2. And from there, we can think about the domain and range. Well, here, our domain is going to be everything, again, except our vertical asymptote. Our vertical asymptote is at 3, so our domain is going to be everything but 3. How do we write everything but 3? We say negative infinity to 3. That's everything to the left of 3. Mathematical and union with 3 to infinity. So there's our domain. We base that again on our vertical asymptote. How about our range? Well, looking at our picture, our range is going to be everything except our horizontal asymptote. Our horizontal asymptote is at 2, so our range is going to be everything but 2. That is negative infinity to 2. Don't include 2, we're getting rid of it. Union with 2 to infinity. Okay, so there's our domain and range. Now, my sketching, we know, is not great, so let's go ahead and use Desmos to sketch a graph of this transform function and just make sure that we seem to have gotten it right. So 1 over x minus 3 plus 2. Looks pretty good. We can see that we have a vertical asymptote at x equals 3, and we have a horizontal asymptote at y equals 2, just like we sketched on our graph. So we did pretty good. All right, let's look at our next one. So the next one, okay, first thing we need to do is think about our basic function shape, right? So how do I know that? Well, again, this is a rational function because there's an x in the denominator. It's got that squaring here. So this is going to be similar to our 1 over x squared graph. So our 1 over x squared graph, right, has L curves in the top right and the top left. So L curves top right and top left. So there's our basic function shape. Now, just like before, it's going to be helpful for us to think about vertical asymptote there and horizontal asymptote here, because it turns out when we're shifting these, it's actually those things that we shift. Okay. All right, now let's look at what's going on over here. Okay, thinking about transformations, we have a negative out in front. What does a negative out in front tell me? It tells me we have an x-axis reflection. What will an x-axis reflection look like? Well, it's going to flip these graphs over the x-axis, meaning my curves will flip down here. So now I've got something in bottom right and bottom left. That's taking the reflection on. Now I've also got a +3. That +3 is inside with the x. That's going to be a horizontal shift left 3. Oh man, I'm writing it again. Okay, left 3. I have a +2 outside of our x variable, so that's going to be a vertical shift up 2. Okay. All right, let's go to our little graph and try and sketch that. Okay, so I'm going to think again about my vertical and horizontal asymptotes and how those move. Well, my vertical asymptote is going to move left 3. 1, 2, 3. So now I have a vertical asymptote here at 3. My horizontal asymptote is going to move up 2. So I have a horizontal asymptote here at 2. And then I'm going to sketch my graph, my reflected graph. So I've got bottom right and bottom left. I'm going to sketch those on sort of my new axis, or my horizontal and vertical asymptote. Man, my sketching's getting worse, I apologize. So there we go. There's our transform function. Again, not perfect, but good enough that I think it'll help us with domain and range. Let's think about our domain. Our domain is going to be everything except this vertical asymptote, or everything except -3. How do we say everything except -3? Well, -∞ to -3, not including -3, union, mathematical and, with -3 to infinity. Whew. So there's our domain. Now our range. Well, looking at our range is everything below our horizontal asymptote, or everything below 2. How do we say everything less than 2? Well, everything less than 2 is -∞ to 2. So there's our range. Phew, and just for fun, since we've got it pulled up here, let's go ahead and look at this graph on Desmos. So f of x equals -1 over x plus 3 quantity squared plus 2. Not bad, that looks pretty similar to what we've got there. All right, so there we go. There's our last little piece here. Our last little piece are our rational function examples, okay? And we just sketched those in. So when n is even, remember that was our L curves in top right and top left, okay? Then our domain, there we go, our domain in that case was -∞ to 0, union with 0 to infinity. Our range was everything above the x-axis, or 0 to infinity. When n was odd, we had that L curve in the top left, and sorry, top right, bottom left. Whew. Our domain was -∞ to 0, union with 0 to infinity. We had to throw out 0. That was where our vertical asymptote was located. And our range was also -∞ to 0, union with 0. Okay. All right, so here are all of the basic function shapes that we have so far. We need to know these, we need to know our domain and range, and we need to know how to transform these. Now we are going to get a couple more basic function shapes in chapter 6. That's going to be our exponential functions and our logarithmic functions. But for now, these are the functions that we need to know, and we need to know how to transform.